Here we have a typical battery limit for natural gas line, and in the left side of the dash point line we have the supplier. In this case is the supplier. It's not a responsibility of the project, because you can see there is any information related to this line. And at the right side of the dash point line we have the responsibility of the project, or responsibility in this case of the company. And what you can see here is that the nomenclature or the letters for battery limits here, it's not in English, it's limite de bateria. We have the information of the fluid. In this case, most often we don't use this designation in the line, we use the line identification that is not shown here. Make sure that you always have isolation valve as close as possible to the battery limit, because you want to avoid any chances of sending flammable gas or any kind of fluids to another person without permission. So this isolation valve is to prevent this kind of situation to happen. We have here a figure 8. A figure 8 is a kind of flange where in one part you have a blind flange, and in the other part you have orifice. So the correct way to read this symbol here is that the circle in white below is the part that is installed in the field. So here it means that the orifice is installed as standard, and the closed part, the isolation part, is not aligned with the line, and that is the opposite here at the bottom. You can see that closer to the line is the black circle. It means that this figure 8 is closed, and here you have the flare. So these lines here is for venting for flare or draining for oily system. So that's why there is a figure 8 here to make sure that the system is isolated. After the second isolation valve, I have my system of measurement. If we are talking about gases, it's very important to have a pressure transmitter or at least a local manometer to verify the pressure that you are receiving the media, because as I told you, you need to comply with the requirements at the battery limit. So our battery limit is here, and as close as possible to battery limit you have the measurement. You will verify if the conditions on the contract are being respected. We have the temperature and we have a flow transmitter. Depending on the kind of flow measurement that are being considered, for instance, if you are using orifice plate, in many cases we do the compensation. We use the pressure and temperature of the fluid in the operation conditions to compensate the information based on the standards condition like 0 Celsius degree and 1 atm. So that is interesting to decrease the error that you can have associated with the operating conditions. Because if for the same orifice plate, if I change the pressure and I change the temperature, although the mass of flow of fluid is the same, the volumetric measurement will be different. That's why we usually have the flow measurements set at a specific pressure and a specific condition.